So I'm going to start a new topic today, and the topic is version control, which is this section here. And we're going to work our way through these slides. Don't know if I get through all of them, but we'll see how far we get. So it's an area that some of you may have familiarity with already, and that's fine. So it'll be a refresher initially anyway. Hopefully we'll get into the area in a bit more depth for you people. But I kind of assume that you have a vague familiarity with it and cover it from the ground up. So the topic is version control. It's also known as source control management. And we're going to cover the topic using a particular tool called Git, which you've already used for me. So we're going to dig a little bit deeper into that tool. But I'll give it a brief sort of background to the area first. There is an online book. I don't require you to necessarily go reading any chapters from this now, but it's a good source if you want to find out a little bit more about Git in particular. The text is quite old, but I have found it useful in the recent past if I wanted to just read up a little bit more on a particular aspect of Git itself. So there's the URL anyway, and I assume it's still available. Actually, maybe it's 2 years or so now since I actually had reason to look at it, but I assume it's still available. Can I just confirm now that you can hear me and you can see my screen, please?
Yeah.
Great. So it's always a good place to start with a definition or a question. What exactly is version control? And I'm saying it's a system that records changes to a set of files over time. And it allows you to recall a specific version of a file from some earlier period in a project. So hence the term version control. We're controlling the evolution of a set of files over time. And what these version control tools allow us to do then is, I'm kind of listing here, it allows us to actually revert or rewind the state of a particular file or set of files. That's 1 and 2. It allows us to compare the changes that have happened to a file over time. And number 4, it allows us to identify who made changes to which particular files and when, and what changes did they make. So it's really kind of a log or a history of the changes that have happened to a set of files, i.e. a project over a period of time. And okay, we call them version controls, which is probably the common term that's used. An older phrase that was used for the more source control management tools, the source kind of referring to source code. So these source control management or version control tools, originally they were only used by software developers, but they're being used now in other contexts as well. Essentially, if your files are any type of text file, then source control tools are very good for managing the evolution of those files. Where they really come into their own is if you're part of a project team and potentially that team is distributed, be it nationally or within a set of physical buildings, I suppose. And it's great for collaboration. So it allows a team of people to make changes to a common set of files without worrying about not being able to undo changes for everybody else, I suppose. So it is very much a collaboration. It's part of a whole suite of collaboration tools that are used by both software development teams and other teams as well. Teams that might be developing just documentation for some other context, where the documentation would be under source control management. Now, so these VCS there stands for version control systems. These VCS systems have been around for quite a while. Git wasn't the first of them. There were ones prior to it. And all I'm just documenting here and in the next slide are the two basic architectures that are used by these tools. So one architecture, it has a very kind of centralized approach. So the picture there on the right, we have a server, and the server is where all of the main copy or master copy of the files that are under control, that's where they reside. And then, individual members of the team, then they have their own laptop or PC, and what they may do in terms of interacting with the central server is they may ask the VCS software. So there's VCS software installed on the server, and there's VCF client software installed on each team member's own personal computer. And so what the person using these PCs can do is they can communicate with the server, asking it for a copy, the most up-to-date copy of a particular file or set of files. They're downloaded to their local machine. They can do some editing of them there, and then they can upload them back to the central server. So this idea of one central server being the location where the master copy of all of the files reside. So it's a very kind of centralized approach. And earlier forms of this VCS software, like there was a tool or a platform called CVS, which stood for a concurrent versioning system. Subversion was another one. Perforce is another one. They all adopted this kind of centralized architecture. And so what I'm saying here is that what team members, there's a kind of a language associated with VCS now. What team members can do is they can pull or check out a particular copy of a file, make some edits, and then commit or push their updated version of the file or their updates to the file back to the central server. And it took care of updating what we call the repository. The repository is the term that we use for where the history of the files are being stored. Here's another, okay, I'm saying down at the bottom, obviously, an obvious disadvantage with this model is that if the server goes down, then nobody has access to the master copy, if you like. That's fairly obvious, I suppose. Here's another kind of representation of the same idea. So my server is on the left, and the term we use really is the repository. So the repository is where the master copy of the various files that make up my project are stored. And then individual team members, they can do things like check out a copy of a file or a set of files, or indeed all of the files that make up a project. They do some updates. When they're working on a file or files, we refer to what they're working on as their working copy of a particular file or set of files. And again, that's a term that I'll use quite a lot. It's just the vocabulary, really. Eventually, when they're finished their editing, they perform what we call a commit of their edits back to the central repository. That's just really saying the same thing. That slide there. Essentially, the repository is just it's a database, really. It's not a relational database, but it is a database. And we know what the notion of a database is. It's a server, so it does have its own URL, and that's how we communicate with it. We don't communicate with it over HTTP. There's a different kind of protocol, but we never see that protocol directly. We just, as a user, we would have some client software on our local machines, which is communicating with server software on the server machine. And I've already introduced this term now, the working directory or working copy. That's what you as an individual, that's what you make edits to. You never make edits to the file as it resides on the central server. What an individual can also do is they can keep track of what edits they have carried out on their working copy, and that can be useful if you're editing multiple files in one session and you just want to try and step back and recall what edits have I actually carried out now on the various files on my working directory. Well, the version control software can tell you that quite easily, rather than you trying to work it out for yourself. The other model then is a distributed model. And in this model, every single person's team member's local computer has a copy of the master, if you like. They have a full copy of the repository, every single one. And as the person on this machine, let's say, they still have to do this kind of idea of checking out a particular file. They make the edits to the file outside of the repository, and then they commit those edits back to their local repository. But what's happening behind the scenes is when somebody makes a commit to their local repository, the VCS software that's installed on each person's computer, they actually tell everybody else, look, this repository has had some commits carried out on it, and those commits are communicated to the other repositories. So all the repositories are in sync with one another. That synchronization is taken care of by the VCS software. You don't have to worry about it as an individual. You just work away with your local repository that resides on your local machine, and the underlying software then will take care of syncing up all of the other ones. That's the way Git works. Not only Git, but there's another one called Mercurial, which works along the same idea. And so the advantage of this distributed kind of approach is that, well, if this person's computer becomes corrupted, that's not a problem because these other two now have a copy of the master. So when we recover this machine, we can just, the VCS software will just ask one of the other members of the cluster to give me your copy of the repository so that it can reset back to where it was. Okay, so that's the kind of distributed model, but we still have this idea of a working copy or a working directory. So the person that's sitting in front of this computer, they're not making direct changes to their local repository. They still have to check out a particular file or set of files, do the edits on their local file system, and then commit those edits back to the repository that rests on their machine. Okay, now we will be using Git, but we're actually going to be using Git predominantly in a kind of standalone mode, you might say. We don't have this kind of distributed system at play. So that's the first point. Now you might ask, where does GitHub come into this? And you shouldn't think that GitHub is essentially, if I go back, that this is essentially kind of the GitHub model. It's not. GitHub kind of falls in between the distributed model and the kind of centralized model. I'm just saying down here that GitHub, you could think of it really as a kind of a backup of a repository that resides on your machine. So if this is your machine, you have a Git repository for a particular project on it, and you push that repository up to GitHub. All GitHub really is just a backup of it. There's no underlying synchronization going on between the repository that resides on your machine and the repository that sits above on your GitHub account. You have to manually push changes up to GitHub. Git won't do that kind of behind the scenes for you. Okay, it's a Git command that you use to push your updates to the GitHub repository, but it's up to you to do it. It's not taken care of automatically, as it would be in the distributed approach to Git, which was on the previous screen. Right, so that's kind of by way of background, I suppose. Just pause for a second in case there are any questions. Now, kind of physically, when I talk about a repository, physically, how can we see evidence of a Git repository on our local machine? Because in the previous screen, I said that the repository actually sits on your local machine. And so really all a Git repository is a folder with lots of files and folders within it. So that's what I'm showing you on this screenshot here. On the left is a screenshot from our little mini product catalog project that you've been working on in the labs. And up here, there within the project, there is a folder called .git. Well, that is the actual repository. And it's just an ordinary folder. If you open it up, then this is what it looks like. So this is the internals of a Git repository. Now, please do not go poking around these particular files here manually, because it's very easy to corrupt a Git repository. And take it from me, if you corrupt a Git repository, it is nigh on impossible to recover it. So just bear that in mind. Okay, just have a look around, and we will actually dig into the internals of a Git repository, not today, but perhaps the next day, so that I can show you exactly what's happening inside there. But outside of that, I would strongly advise you to never go near the internals of the Git repository. Only just use the Git commands that you know. The Git commands that you submit from the command line, they're all kind of interacting with these files and folders, but they're doing it in a kind of controlled way, if you like. So I'm saying down here on the bottom left that the .git folder, that always has to reside in your project's base folder. So if I just flip over to the equivalent of kind of Windows Explorer. So here's my Mocha lab. If I go into that folder, now what I'm going to do is actually switch off what are called hidden files. Okay, so this looks familiar. My package.json, package lock, my source folder, my test, my node modules folder, test folder, etc., etc. I don't see the .git folder that I was mentioning on the slides here. And so this might be the case in terms of your computer as well. I'm sure you're aware that in be it Windows or Mac, files or folders that begin with the dot character, they're referred to as hidden files or hidden folders. And maybe the default setting on your computer is that hidden files or folders should not be displayed. As we can see here now, I've turned off hidden files, so I can't see them. So I have to enable them. Now it's just a keyboard command that I'm submitting now. And when I do it, now I see my Git repository or my .git folder. And I can just double click on it to go into it. And this is the internals of it that I was showing you on the screenshot. So physically, that's what a Git repository is when it resides on your local computer. It's just a folder with lots of content within it. Oh yeah, the other thing I'm saying down at the bottom left here is that I'm using that term, your working copy of your working directory. So if this is my entire product catalog folder, okay, this is where the repository resides. Everything else constitutes the working copy or working directory. So if I want to do some edits, it's these files and folders here. That's where I do my edits, carry out my edits. And you kind of know this already. And then when you've done some editing and you want to commit those edits to the repository, okay, we use a git command. When you do that, then what happens is the edits that you've made are recorded somehow inside here. We'll actually see later on how they are recorded. So if I want to use Git, how do I start using it? I have this project that I'm working on, and I want to use Git to manage the history of all the changes that I'm going to be carrying out on the various files. The first thing you've got to do is create your .git folder. In other words, create your repository. And the command to do that is this. So when I submit that command, it's going to go along and create this folder, and it'll have quite a lot of content within it, even though there's no record of my project files and folders. All of this kind of scaffolding is taken care of when you create an empty repository. So that creates an empty repository for you. The next thing that you must do then is that you must run this command. You must run it from the base folder of the project that you're working on. Don't be down in a subfolder or subfolder, because what happens then is it puts the repository down inside in that subfolder, and that's not really where you want it. So that's just a reminder. Next, I'm saying the next thing you do is you want to kind of record the very first version of your project files in the repository. Now, there's two commands that you have to submit to do that. Later on, we'll explain what's the difference between this command and this command. Just for now, take it from me that you have to submit both of these commands. And having done that, now there is the initial version of your project has been stored inside in the Git repository. Okay, so if I go back to the previous screen, if I submit those two commands, then what has happened is Git has taken all of this stuff here and it has somehow made a copy of them inside in the Git repository. Now, take it from me, if you go looking inside here, you will not find a file, for example, called package.json or any of the other files. You won't find them that way. They're recorded very differently, and we'll see later on how they are recorded. But that's what the git add and git commit commands do. They essentially take a snapshot of your entire project and store it within the repository. So we've done that. And the repository now has my first version, if you like, of the project. How does Git or the other version control tools, how does it actually store stuff? In what form does it store your project files? And there's kind of the old way and the new way. The old way is how they used to do it before Git. So other version control, older version control tools, what they actually did was they stored a delta of the changes that you've made. Now, what I mean by that is, supposing I've got a project and it's just made up of 3 files, let's say. Initially, I've got three files, and let's suppose there's a tiny bit of content in each of those. So when I do my first git commit these 3 entire files will be stored in the repository. Then let's supposing I decide I want to make some changes to file A and file C. So I make those changes out in my working directory, and then I commit those changes to the repository. Now, what older tools used to do is they used to work out where have you made changes, and it used to actually record the delta of the changes that you've made. In other words, the difference between the previous version and the current version. That's what I'm calling the delta. So it just recorded the changes that were made. Then later on, maybe I want to do some more editing. I want to do some editing to file C, and I commit that change. It records the delta. What has changed to file C between here and what you now have in your working directory, and on it goes. So it's always just recording essentially kind of the updates that you have made to a file or files. The downside of that approach is if I want to find out, well, what was the status of file B at this stage here, then what the source control tool has to do is it has to kind of work its way back right to the beginning, take the initial version of the file, and then incrementally add all the deltas that you carried out in order to create the complete version of the file as it might have existed here. So for file A, it would start with this, then apply that change to it, then apply that change to it, and then show you what the outcome of applying those 2 changes were. So it was pretty inefficient. It was efficient from a memory storage point of view, but it was inefficient if we wanted to, ask the repository, what's the status of a file at any particular point in time. It had to kind of construct it itself. Git doesn't work that way. This is the way Git works. So again, we have the same kind of scenario. I've got 3 files that make up my project. Essentially, every time I make a change to a file or files and I commit those changes, what Git will do is it will store an entire copy of the new form of the file. And that's what I'm trying to represent here. So that now means if I ask Git, can you show me the status of file A and file B when I made this commit here? Well, it has an actual full copy of it, and it can just throw those back to me straight away. It doesn't have to construct them. So that's the way Git physically stores your updates to files in the repository. So I'm saying here, every time you save or commit file state changes from the working directory, they're stored as complete snapshots of the. In fact, what happens is it takes a snapshot of the entire project. Now that may sound inefficient, but it's kind of clever in the way that it does it. Whereas in the previous screen, it was taking deltas rather than complete snapshots of files. So here I'm saying it is faster. Okay, that's fine. Now again, so the working directory is where I carry out my edits. And so it means that at any particular point in time, my working directory could be in one of these 3 states vis-a-vis the repository now. So the whole idea, I guess, of version control is that the repository is trying to stay in sync with your working directory as much as possible. So at any particular point in time, if I'm just making changes to files, committing them, and I'm working on in that fashion, every now and again, I want to find out what is the status of my working directory. When we talk about status now, we're talking about the status of the working directory as opposed to the status of the repository. So the status of your working directory at any particular point in time will be one of these 3. We say that your working directory is in a committed status. What that really means is that the repository is completely in sync with your working directory. it has the most up-to-date version of every file in your working directory. That's the committed status. The modified status means that you've made a commit to the repository, but then you did some edits in the working directory. So now we would say that your working directory is in a modified state. It has changes made to files that have not yet been recorded in the repository. So we'd say that the repository is out of sync with your working directory. And the third, those two are easy enough to understand. The third one is a little bit vague, and it's kind of difficult to explain until we get into understanding a little bit more depth how Git works. The third status that your working directory might be in is what's called a staged status. And the only way I can explain that at this stage is to say you have made edits to files in your working directory. You haven't committed them yet, but you have told Git that you have made some edits to those particular files. So it knows that you have files that you have modified. Git knows that, but you haven't actually committed them yet to the repository. So if that's the situation, we would say that our working directory is in a staged state. Now, again, I say, if that's a little bit woolly or a little bit unclear, then I'm not surprised, because we need to cover a little bit more detail to appreciate what this actually means. The other two are fine. So maybe we just have to leave that for now, and we'll certainly come back to it in a couple of slides' time. So again, it's the status of the working directory is what I'm talking about here. So this is a fuller kind of explanation of the typical kind of operations that you carry out as a developer on your project when you're using Git. So the starting point for any project is you've got your project folder. Maybe you have broken it up into subfolders and subfolders. You've got an initial kind of structure for your project. And maybe you've even got some files with some content in them. That's all part of setting up the actual project that you're working on, be it a development project or otherwise. So having done that, the first thing we need to do then is, in terms of Git, is we need to create an empty Git repository. And I showed you a while ago, that I mentioned a while ago, that you just type the git init command to do that. Make sure you type this from the base folder of your project. So we now have a local Git repository, or physically we have a .git folder within our project folder. Number 3, then you add the initial project state, all the files and folders that you set up here. You add those to the repository. Although I'm saying here, you add them to the repository's staging area. So this is kind of harping back to what I was saying on the previous slide now. When you type the git add command, essentially you're telling Git about various files and folders that you are about to commit, but not fully commit yet. You're kind of telling it about files that you have created or modified. That's what the git add command does. So at this stage now, Git knows about files and folders that are in your working area that you are going to commit sometime in the future. The next thing you do is you actually submit the git commit command. And at this stage now, you have fully committed your files and folders to the repository. So this is the first time I've done a git commit, and this is the first time I've done a git add. So we can say at this stage now that I have version 0. I'm just deciding to start at 0 rather than 1 for no particular reason. I'm saying I have version 0 of my project history is now recorded in the repository. So version 0 will know the full initial folder structure that I created up here. It will have a copy of the various files, initial files that I created and their content. It has a record of all of those at this stage when I've gotten as far as here. So in a sense, it has a complete snapshot of my project folder and file structure as I created initially. Now we can say that the repo and my working directory are completely in sync. Again, you have to be comfortable with the kind of the language that I'm using here when we're talking about Git. My working directory and my repository are in sync with one another. Typically, then what you might do is you go off and you do some development work. So you're adding some more content to files that you created up here, or indeed you may create some new files and new folders and put some content into them. So you're doing your normal kind of editing, if you like. All of that work is being carried out on what we refer to as the working directory of my project. Then you stage those changes that you have carried out up here. In other words, you type the git add command, command. Again, it's a tiny bit vague, but you're essentially telling Git that I am about to commit some changes to the repository, but I'm not fully committing them yet. That's kind of what the git add command does. Having done the git add, then I actually do a git commit. And so now I have version 1 of my project. I have a snapshot of version 1 of my project in the repository. So I have 2 versions. Hence, I have a bit of history of the changes that have happened to my project over time. And you carry on in that fashion. So you're back up to here, you're doing some editing, you're staging, you're committing, more editing, stage, commit. You have to stage before commit. You can't do a commit without having done a staging operation first. That's just the way Git kind of works. You kind of have to accept it as being that way, if you like. So I'm saying here, note, okay, we should use something called branching here, which I'll cover the next day, really. So this is your kind of classic mode of operation when you're using Git. And my guess is, well, certainly in the labs with me so far in this module, you have been doing 5, 6, 7. I did this for you. I gave you a project with a Git repository in it already, but 5, 6, 7 you've been doing all along. If we take one particular file now, and again, I'm going back to this notion of the status of a file, a particular file. Status now again means comparing the file in the working directory to what the repository knows about your file. And I'm saying at any time, the status of a particular file in your working directory is one of these 4. And again, it's just more terminology. If we were to say that a particular file is in an untracked mode, or untracked status, sorry, what that means is you have just created a new file, put some content into it, and there is no previous version of that file in the repository. Git, in other words, has no knowledge of the existence of that file so far. So we would say from a status point of view, that file is in an untracked state. The next one is unmodified. An unmodified file is a file that's in your working directory, but the repository has the most up-to-date version of that file. So the repository and the working directory are completely in sync. So the term that we would use from a status point of view is to say that that particular file is in an unmodified status in your working directory. Modified is where you've made some edits to the file in your working directory, but you haven't actually committed those edits to the repository yet. So we would say that file is in a modified state. And last but always not least, this idea of a staged status for a file. That means you have modified it, you've told Git about it, but you haven't committed it yet. These are a little bit tricky, but it's important that you are clear on what each of these mean. If I go back to unmodified, an unmodified file is one that Git already knows about because you have committed it previously. And if you have committed it previously, then we would say that Git is tracking the status of that file. It's tracking it, but it's unmodified in the sense that it has the most up-to-date version of the file in the repository. Modified status is a file that is being tracked. You've modified it, but you haven't staged it yet. And then finally, staging means it's tracked, i.e. the Git repository has a record of it from a previous commit. It knows that you have modified it because you have staged it, and it's also staged, but not fully committed. Right, it's all kind of wordy stuff. Maybe when we start using the commands, which I think I do on the, I'm going to skip over that slide. It kind of tells you the same story as the previous one, but in a kind of diagrammatic way. Okay, in this slide and the next two, I'm trying to reinforce this idea of the status of a file or the project in your working directory vis-a-vis the repository. So the command that we use if we want to find out information about status is, surprise, surprise, the git status command. And what I'm showing you here is a kind of a scenario that I kind of created for the project catalog mini project that we're working on. So I typed at some stage as I was working my way through creating this little project for you, I typed the command git status from the command line. And you can do this, and you will be doing it in the lab accompanying this set of slides. And when you type that command, this is the kind of response that you get back from Git. Now, what this is telling me is I have actually made changes to this file and this file since I committed the last time, since my previous commit. So I've actually modified some files, and these modifications that I've carried out, there's no record of them in the repository yet. So it's saying these are changes that you've made and you have not staged them or committed them, as it turns out, but I haven't staged them. It's also telling me that I created this file since my previous commit. So this is a completely new file. And I said from the previous slide that if you create a completely new file and put some content into it, and it's a file that you've never committed so far, then we would classify from a status point of view, we would classify that file as being in an untracked status. And that's exactly what it's telling me here. So let's supposing, so this now is, this is the status of my entire working directory. There are two files that have been modified, and there's a third file that's new and hasn't been sent, or the Git repository has no information about it so far. There may be other files as well in my working directory. In fact, there definitely are, but those other files, I haven't made any changes to them. There are previous versions of them in the repository, but I haven't made any edits to them recently. It doesn't bother telling you about those here. They would be classified as unmodified files, but it doesn't tell you about those because, in a large project, there could be a couple of hundred of those, and you're not really interested in knowing about those. These are the ones that you want to know about, and this one here. So let's suppose that's the status of my working directory for this project that I'm working on. Let's supposing the next thing I do is I submit this command here. This is our infamous staging command. So I do git add -a. -a essentially means stage everything. By everything, I mean everything that has been modified or every new file that has been created. That's what the -a means. Now, when I do that, and then I ask git again, can you now tell me the status of my working directory? What it gives back to me is slightly different. It's now telling me that there are some changes to be committed. So it actually knows that you have staged them, but you haven't committed them yet. Contrast that there with what it said here. It's saying these are changes not staged. Whereas when I have carried out this operation, it now knows that these are changes that have been staged, but they are not committed yet. They are to be committed. And it's listing everything. In this case, it's both the modified ones and the new ones. So now this is now the status of my working directory. It has altered because I've carried out this operation here. Let's supposing the next logical thing that I would do is submit a git commit command and include a message. Note in the git commit command, you don't specify what files you are committing. By default, and you can't change that default, what you are committing is essentially what you have staged up to now, or what you have staged prior to trying to submit a git commit command. So anyway, I submit this git commit command, and okay, I get some response back, and then I try git status again. I'm asking git again, what is the status of my working directory? And now it's telling me this. I have nothing to commit, which is correct. And this is another way of saying that your repository is completely in sync with your working directory, or vice versa. And that kind of makes sense based on based on what I've done here and the previous kind of git add command that I showed you. The git commit command also, as you can see here, tells me how many files you have updated to your repository. And it's saying in this case, there are 3 files, which of course is correct. There was 2 modified ones and 1 completely new one. We'll actually make sense of this other, this stuff here as well later on. In fact, it's giving me a little bit more information. It's telling me in a bit more detail how many new lines were added to my repository and how many lines were actually deleted. So it's possible, maybe we don't know, but maybe the changes that I made to this file here might have involved adding some new lines of code and getting rid of existing lines of code. The same might have applied to this one here. So it actually knows with a fair degree of precision the volume of changes that have happened to the files, to the 3 files that you have. Well, there's only 2 of them really that have been modified. The volume of changes that you are committing to the repository, if you like. Okay, I should halt it there really, I suppose, even though that's what I've just talked my way through there now. That's pretty important that you are comfortable understanding it. So play around with it yourself or go back and re-review the recording maybe to ensure that you're happy with this whole idea of a working directory, the repository, and this idea of the status of the working directory, and by implication, the status of a particular file in the working directory.